When dealing with poor electrical work, it is important to consider several factors. Firstly, think about confronting the individual who performed the work. Approach them privately and respectfully. Express concerns in a non-accusatory tone, avoiding harsh language or insults. Provide specific examples of the poor workmanship, referring to code violations or industry best practices. Clearly explain the potential safety hazards associated with the work and offer suggestions for improvement or ask for clarification on their reasoning. Secondly, when faced with non-compliance, if the individual is unresponsive or dismissive, document the conversation with dates, times, and any witnesses present. Contact the appropriate authorities, for example, the building inspector or licensing board, to report potential code violations. It is also a good idea to consider hiring a qualified electrician to inspect and rectify the work. When it comes to unused conductors in Romex, the National Electrical Code, or NEC, does not explicitly prohibit them. However, it is generally considered best practice to cap or tape off any unused conductors to prevent accidental contact and potential hazards. Unused ground wires should never be cut off. They should be terminated properly in a junction box or at the electrical panel. There are situations when it might be appropriate to ignore poor work. This includes if the work poses no immediate safety risk and is unlikely to cause harm. Also, if confronting the worker is not feasible or productive, or if the property is not yours and you have no authority to intervene. Some additional tips to remember are to always prioritize safety and code compliance. Be professional and courteous, even when dealing with poor workmanship. Document all interactions and observations and, if necessary, seek assistance from qualified professionals or authorities. It is important to remember that the ultimate responsibility for ensuring electrical safety lies with the homeowner or building owner. When discussing electrical systems, it is vital to understand some fundamental concepts. In residential wiring, common voltage levels are 120 volts and 240 volts. These voltages are used for different types of appliances and circuits. For example, lighting and small appliances typically operate at 120 volts, while larger appliances like electric stoves and dryers require 240 volts. When running electrical wiring, it is essential to follow the National Electrical Code, or NEC, which provides guidelines for safe and proper installations. The NEC covers various aspects of electrical work, including wire sizing, circuit breaker ratings, grounding, and bonding. One important aspect of electrical safety is grounding. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Ground wires are typically bare copper or green insulated wires. They should be properly connected to the grounding system at the electrical panel and at each outlet or fixture. Bonding is another important safety measure. Bonding involves connecting all metal parts of an electrical system together to create a low impedance path for fault current. This helps to minimize the risk of electrical shock. When working with electrical wiring, it is crucial to use the correct wire size for the circuit. The wire size is determined by the amperage of the circuit. The NEC provides tables that specify the minimum wire size for different amperage ratings. For example, a 15 amp circuit typically requires 14 American wire gauge, or AUG, wire, while a 20 amp circuit requires 12 AWG wire. Circuit breakers are designed to protect electrical circuits from overcurrents. Overcurrents can be caused by short circuits or overloads. When an overcurrent occurs, the circuit breaker trips, which interrupts the flow of electricity and prevents damage to the wiring and appliances. It is important to use the correct size circuit breaker for the circuit. The circuit breaker rating should not exceed the ampacity of the wire. For example, a 14 AWG wire is typically protected by a 15 amp circuit breaker, while a 12 AWG wire is typically protected by a 20 amp circuit breaker. When installing electrical outlets, it is important to follow the NEC guidelines for spacing and location. Outlets should be spaced no more than 12 feet apart along walls, so that no point along the wall is more than 6 feet from an outlet. Outlets should also be located in convenient locations, such as near doors and windows. When working with electrical wiring, it is important to use the proper tools. These tools include wire strippers, pliers, screwdrivers, and a voltage tester. Wire strippers are used to remove the insulation from wires without damaging the conductor. Pliers are used to grip and bend wires. Screwdrivers are used to tighten and loosen screws. A voltage tester is used to check for the presence of voltage. It is important to use a voltage tester before working on any electrical circuit to ensure that the circuit is de-energized. When making electrical connections, it is important to use the proper wiring methods. These methods include using wire connectors, such as wire nuts or terminal blocks. Wire connectors should be sized correctly for the number and size of wires being connected. The connections should be tight and secure to prevent loose connections, which can cause overheating and fires. When running electrical wiring through walls and ceilings, it is important to protect the wiring from damage. This can be done by using conduit or cable protectors. Conduit is a metal or plastic pipe that protects the wiring from physical damage. Cable protectors are plastic or metal sleeves that protect the wiring from being damaged by nails or screws. When installing electrical fixtures, it is important to follow the manufacturer's instructions. These instructions will provide guidance on how to properly install the fixture and make the electrical connections. It is also important to ensure that the fixture is properly grounded. When working with electricity, it is important to be aware of the potential hazards. These hazards include electric shock, electrocution, and fires. Electric shock can occur where a person comes into contact with a live electrical conductor. Electrocution can occur where a person receives a lethal dose of electricity. Fires can occur when electrical wiring overheats or when there is a short circuit. To prevent electrical hazards, it is important to follow all safety precautions. These precautions include wearing rubber gloves and safety glasses, using insulated tools, and energizing the circuit before working on it. If you are not comfortable working with electricity, it is best to hire a qualified electrician. A qualified electrician has the knowledge and experience to safely and properly install and repair electrical systems. When hiring an electrician, it is important to check their credentials and ensure that they are licensed and insured. You should also ask for references and check their online reviews. In commercial and industrial settings, electrical systems are often more complex and require specialized knowledge and skills. These systems may include three-phase power, high-voltage equipment, and complex control systems. Three-phase power is a type of electrical power that is commonly used in commercial and industrial settings. It provides a more efficient and stable power supply than single-phase power. High-voltage equipment is used to distribute electrical power over long distances. This equipment includes transformers, switchgear, and power lines. Complex control systems are used to automate and control electrical equipment. These systems may include programmable logic controllers, or PLCs, and human-machine interfaces, or HMIs. When working with electrical systems in commercial and industrial settings, it is important to follow all safety regulations and guidelines. These regulations and guidelines are typically more stringent than those for residential settings. It is also important to have the proper training and experience. Working with electrical systems can be dangerous, and it is important to take all necessary precautions to prevent accidents. Proper grounding and bonding are critical in all electrical installations. The purpose of grounding is to provide a low impedance path for fault current to return to the source, which helps to trip the overcurrent protection device, such as a circuit breaker or fuse. This protects people from electrical shock and prevents damage to equipment. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. This helps to ensure that all metal parts are at the same potential, which reduces the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding. These requirements vary depending on the type of electrical system and the application. It is important to follow the NEC guidelines carefully to ensure that the electrical system is properly grounded and bonded. Electrical panels are the central distribution point for electrical power in a building. They contain circuit breakers or fuses that protect the electrical circuits from overcurrents. Electrical panels should be properly labeled to indicate the circuits that they serve. The labels should be clear and accurate. It is also important to keep the electrical panel clean and free of obstructions. Over time, electrical panels can become corroded or damaged. If an electrical panel is damaged, it should be replaced by a qualified electrician. Electrical safety inspections are an important part of maintaining a safe electrical system. These inspections can identify potential hazards and ensure that the electrical system is in compliance with the NEC. Electrical safety inspection should be performed by a qualified electrician. The electrician will inspect the electrical panel, wiring, outlets, and fixtures. They will also test the grounding system and check for any potential hazards. If any hazards are found, the electrician will recommend corrective actions. Surge protection is another important aspect of electrical safety. Surges are sudden increases in voltage that can damage or destroy electronic equipment. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors are devices that protect electronic equipment from surges. They work by diverting the surge current away from the equipment. Surge protectors should be installed at the electrical panel and at individual outlets. Arc fault circuit interrupters, or RSIs, are a type of circuit breaker that protects against arc faults. Arc faults are dangerous electrical conditions that can cause fires. They occur when there is an unintended arc of electricity between two conductors. RSIs are designed to detect arc faults and interrupt the flow of electricity before a fire can start. The NEC requires RSIs in many circuits in new construction and renovations. Ground fault circuit interrupters, or GFCIs, are another type of circuit breaker that protects against electrical shock. GFCIs are designed to detect ground faults and interrupt the flow of electricity before a person can be injured. Ground faults occur when there is an unintended path for electricity to flow to ground. The NEC requires GFCIs in many locations, such as bathrooms, kitchens, and outdoor areas. Electrical codes and standards are constantly evolving. It is important to stay up to date on the latest codes and standards to ensure that electrical systems are safe and in compliance. The NEC is updated every 3 years. It is important to use the latest version of the NEC when designing and installing electrical systems. Many states and local jurisdictions also have their own electrical codes and standards. It is important to comply with all applicable codes and standards. Continuing education is essential for electricians. It is important to stay up to date on the latest technologies and techniques. Continuing education courses can help electricians improve their skills and knowledge. Many states require electricians to complete continuing education courses in order to renew their licenses. Electrical apprenticeships are a great way to learn the electrical trade. Apprenticeships provide on-the-job training and classroom instruction. Apprentices work under the supervision of experienced electricians and learn all aspects of the electrical trade. Upon completion of an apprenticeship, apprentices are eligible to become licensed electricians. Electrical safety is a shared responsibility. Everyone should be aware of the potential hazards of electricity and take precautions to prevent accidents. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Remember to always prioritize safety when working with electricity.